Hi, I'm Duana. I'm not a maths person. I'm more of a language person, but all sorts of people can do maths. A lot of us, however, bum out at fractions. If you are like me and you found fractions hard, I'm here today to validate you and say they are hard. They were a sophisticated concept, and we're going to go through one of the common rules today, and I want to show you how much is actually behind it and how interesting it is. Because I'm a language person, let's talk about the word. So actually, fractions, it's a common word in English, and I didn't have a problem with it. It has a Latin root, I don't know how to pronounce this, frangere, which means to break. So it's really like a broken part instead of the whole. So one of the first rules we learn is how to add fractions. So let's take an example, 2/3 plus 4/5. If you were a kid and you just learnt addition and you didn't know how to do this, you might guess, okay, look, I'm gonna use my addition and my pattern matching skills and do 2 plus 4 is 6 on the top and 3 plus 5 is 8 on the bottom. That's actually a really reasonable thing to do. If they went further and reduced that fraction and realized that's actually 3/4, that's great. We should absolutely praise kids if they get this result. What we then need to do is help them go further and validate whether their result matches their intuitions from the real world. So let's take a real world problem. Cake. Adding pieces of cake. So let's imagine that I've got 2/3 of a cake, maybe one of my friends had a birthday party and they really didn't eat much of their cake. They gave me 2/3. And then another friend from another party, they had even less. They had, they only ate 1/5 of their cake. So I've got 4/5. Drawing fifths is a bit difficult. Bit of a Pac-Man situation here. So when I look at these pieces of cake, and I can see that I've got more than half a piece of a cake here, and more than a half a piece of a cake here. So I expect to have at least one cake, not 3/4 of a cake. So something's gone wrong, it doesn't match up. If we visually inspect it, I could say, oh look, I could, cut off a bit of the cake from this one and fill it in here. So I just move that bit of the cake around and I can see, okay, that's actually more closer to 1.5 amount of cake. So what's going wrong here? Well, there's nothing necessarily going wrong there. It's just that if we were to add fractions like that, it wouldn't match up with our expectations from the real world. So the way we actually learn to add fractions, let's go back to my 2/3 and 4/5 pieces of cake. So what we're going to do this time is get them into the common denominator, which is a rule you might remember. So we say, well, a common denominator is 15, because 3 goes into 15 and 5 goes into 15. And 3 goes into 15 5 times. So then I say 2 times 5 is 10. So 10/15 is the same as 2/3. Similarly, 5 goes into 15 3 times, 4 times 3 is 12. So I've got 12/15, equivalent to my 4/5. And what this means on our cakes is that I take each third of the cake here and I split each third into 5 pieces. And so I've actually got now 10 pieces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for the fifths, I slice each fifth of a cake into 3 to get thirds. not very good equal pieces here, but now I should have 12 if I were to add them up. So there's the 10 and the 12. Now that we've got the common denominator, we can add them up. And we've got 22 on 15, which is actually 1 7/15, which is close to 1.5. So this is matching what our expectations were. And what we can do here is say, okay, if I want to fill in this bit of the cake, I need 3 extra pieces here. So I can grab 3 pieces from there and chuck them over here. So I grab these 3. Whoops. And I put them in here. And now you can see that's a more precise way than I did the previous time. This is a visual explanation of what's going on when we get taught the common denominator rule. There's also an algebraic version of it, which I'd like to show you today. So, again, because I'm a language person, I just want to really quickly detour about the notation 2/3 or 2/3. So we kind of just really early on learned that the bar means the fraction 2/3. It kind of makes sense if I've got 3 pieces of equal part and I take 2 of them, I've got 2/3. But another meaning for this bar is 2 divided by 3. And division is an interesting operation. It's actually also hard. It's the hardest of the 4 arithmetic operations because it's going backwards from multiplication. I'll give you an example. So let's take an easier example because I can't do 2 divided by 3 in my head that easily. 6 divided by 3. It's 2. What this division thing is, it's actually saying, okay, 6 divided by 3 is some number. That number, when I multiply it by 3, is going to give me 6. So this is the going backwards thing where I'm like, what number when I multiply it by 3 will give me 6? And because I happen to know my times tables, I know that 2 is that number here. For 2 divided by 3, however, what is that number? So following our rule here about division, whatever that number is, when I multiply it by 3, it has to give me the number 2. So when we're first learning to count, we've got, these natural numbers going on, and we've got 0. Are any of these numbers one of these possibilities? It can't be 2 because 2 divided by 3 can't be itself. It has to be smaller than 2. It can't be 1 because 1 times 3 is 3, and that's not 2, it's greater than 2. And it can't be 0 because 0 times 3 is 0. So if it's not 1 and it's not 0, I don't have any other numbers that I know of that it could be. So what fractions are, in this case where the denominator is greater than the numerator, it's actually saying it has to be whatever, we don't know what this number is, but whatever it is, it's in between 0 and 1. And maybe because we didn't have a symbol for it at the time, we're like, you know what? We don't have a symbol for that specific number that is 2 divided by 3, so let's just write it as 2 divided by 3. And, okay, that's a bit busy. Let's get rid of the dots there and let's just all agree that that is that number that solves that situation. And similarly here, that number, 2 times 3 is 2. And that kind of matches up with our algebraic rule as well. So that's how I now think of fractions. And when you go to add them, our sum of 2/3 plus 4/5. But this time we're going to rewrite it a little bit so we can see algebraically why the common denominator system works. So 2/3, well, it's a third, 1/3 plus another third gives me 2/3. And because that's the case, I can actually write 2/3 as 2 times 1/3. And similarly for 4/5, 4/5 is actually 4 times 1/5. When I have it in this format, it reminds me, of algebra. One of the first rules we learn is if you have things that are the same, you can add them together. So if I have 2A's and 4A's, I have 6A's altogether. That's kind of what is happening when we try to add just the top. We've got a 6 here. But if I look at my fractions, I don't have the same number here. I don't have, if this was an A, this is not an A, this is a B. So what I've actually got is 2A plus 4B. And 2A plus 4B is not equal to 6A. I can't add them together, they're apples and bananas. So that's why we can't add the way we do there. So what do? Well, we can write this again in our common denominators, so into 15ths. 1/3 is 5/15. So I've got 2 times 5/15, and 4 times 1/5 is 3/15. But these still aren't the same numbers. I still don't have 2 A's here. So I have to rewrite it out again. So I can actually write this as 2 times 5 times 1/15 and 4 times 3 times 1/15. And now I have 2 numbers that are the same, and I can do my algebraic rule of adding them together. So 2 times 5, I've actually got 10/15 here. 4 times 3, I've got 12/15 over here. So I've got 10 plus 12 is 22/15, which was our answer from before. So that's the algebraic explanation of getting these numbers to have the same, well, we actually call this the same unit. Because this is, oh, just lost my flower, all good. This is the interesting, sophisticated idea that fractions brought and actually extended our number system when we just had whole numbers. If I just did the normal addition of 2 plus 4 equals 6 with whole numbers, actually what's hidden in here is this unit of 1. 2 times 1 plus 4 times 1 equals 6 times 1. That is the, that common A that we need to do addition. And here I've got different units. I've got thirds and fifths. And that's why for addition in this way, we've got to get it into the common units or the common denominator. So that's it. We've just gone through what is one of the earliest rules we learn, adding fractions. And I just wanted to show how sophisticated that rule actually is. So, if you did find fractions hard, like me, that's totally understandable. And I hope I've encouraged you to maybe play around with things and try to form an understanding yourself. Thanks so much to my camera team, Kat and Colin, and I would love to hear your feedback. Happy maths.